Welcome back. So what we still need to do is look at how the margin of error is affected if we now decide that the level of confidence we'd prefer is 99%. So I'm going to use the same formula for the margin of error. And again, it's the same point estimate we had before, namely 0.34. But the alpha is going to be different, right? For 99% confidence, alpha would be, remember how that goes, it's 1 minus the confidence level as a decimal. So, oops, 0.99. So alpha would be 0.01. So that gives us a different alpha over 2, which is going to give us a different z sub alpha over 2. Let's see, alpha over 2 is going to be 0.005, and we'll use the table then to figure out what z sub alpha over 2 is. Okay, so I'm looking for, so again, I'm looking for z sub 0.005. Okay, so looking for 0.005 in here, let's see, and I'm going to want this part of the table, 0.005. If you're not sure which part of the table you want, that's okay, it's not a big deal. It's just that over here you won't find 0.005 because this part of the table is for z values to the right of the center. So remember, the center of the standard normal is at 0, and so the table with the positive z values is to the right. So all of the areas that are to the left of the z value here are going to be more than half because you've got more than half the area. So if you go looking in here for whatever it is that we're looking for, 0.005, you just won't find it, and you'll go, oh, okay, I guess I must need the other part of the table. So not a big deal if you're not sure right off the bat which part of the table to look at. There's only one part that you can find your number on. Okay, so 0.005. You've probably already found it because you're not trying to talk and look and write at the same time. Okay, right in here. So it looks like minus 2.5, 2.57, I'll say. And again, just to remind you, what I used the table for was to find the z value that had 0.005 area to the left of it. The table gave us negative 2.57. What I actually want, though, is the z value that has 0.005 to the right of it, but I know that this is centered around 0, and that to get that same amount of area to the right, I'd go the same distance to the right as the table told me I had to be to the left. So you just use the table to get this number and take the minus sign off to get that number. Okay, so there's our z sub alpha over 2. We've got everything we need to plug into the margin of error formula then. So remember, the margin of error formula is z sub alpha over 2 square root of p hat times 1 minus p hat over n. Plugging our numbers in, we have 2.57 times the square root of 0.34, 1 minus 0.34 over 800. And if you crunch numbers there, you get 0.043. Notice that is larger than the margin of error that we had gotten previously. So this is the margin of error for 99% confidence. This is the margin of error for 95% confidence. So let's get sort of a visual of what's going on here. So we really came up in a way with two confidence intervals. So let's say here's our number line with possible proportions on there. Our point estimate was 0.34, and then in what we did first was we found a confidence interval, 95% confidence interval. We found the lower bound was 0.307, the upper bound was 0.373. Okay, and that was our 95% confidence interval. Then we switched over to 99% confidence, and remember the margin of error is how far you go to the left and right of your point estimate. So then we repeated the calculation for the margin of error for 99%, and we got a larger margin of error. We got 0.043. So if I go 0.043 to the right, so I go further to the right now, 0.043 to the right of 0.34, I'm going to get to 0.383. Okay, so this is the larger margin of error to the right. If I go 0.043 to the left from 0.34, so I'll get down to about there, 0.297. That's then the confidence interval that you would have for 99% confidence. Maybe we should label the margin of error on here just to remind ourselves. That margin of error was 0.033, and then we also computed the second margin of error for the 99% one. That was 0.043. So what I want us to take away from this part of the example is that when you go for a higher confidence level, you end up with a larger margin of error. And that kind of makes sense, because if you allow more possibilities here, there's let me just informally say there's a greater likelihood that this interval is going to encompass the true proportion. So it's like you're spreading a wider net, and so you're more likely to get what you want, is in a very informal way of saying that. Let's see, and I think I have a spot on the notes for us to say something about that. Yes. So again, the takeaway from this last part of this example is that as the level of confidence increases, the margin of error must also increase. So in other words, for higher confidence, you get a wider interval. So now we come to the time for you to try to put the pieces together yourself in a Build Your Understanding problem. A survey of 2,306 adult Americans found that 417 have donated blood in the last 2 years. Obtain a point estimate for the population proportion of adult Americans who have donated blood in the last 2 years. And then construct a 90% confidence interval for the population proportion of adult Americans who have donated blood in the last 2 years. So good luck with that, and we'll go over it together in the next video.